Previously, we developed a formula for finding arc length of a curve from some point A to some point B. Let's look at an example here. Let's find the length of this curve, y equals x to the 3/2 from x equals 0 to x equals 4. And recall that our formula was the integral from a to b square root 1 plus the derivative of our function squared with respect to x. So first we're going to have to figure out what is the derivative of our function, square it, and put it in this formula. I like to just go ahead and do this part separately and then put that into the formula. So here's our function. So let's figure out what our derivative is first. So power rule there. 3/2 comes down. Lower the degree by 1. So 3/2 x to the half. And then we want that squared. So 9/4 x. Now, plug into our formula here, the length. So remember, the idea is we're chopping this thing into a bunch of little line segments, and we partition the x-axis. We're starting here at x equals 0, going to x equals 4. And then we have the square root of 1 plus 9/4 x. Now, if this was just square root of x, it'd be no problem. So we're going to need to do something to reduce this down. We can use a u substitution. Now, previously I had talked about linear u subs. This is a linear expression, so to do a u substitution, all I'd have to do is remember to divide by that 9/4. So let's take advantage of that shortcut. So if I divide by 9/4, that's like multiplying by 4/9. And then that's 1 plus 9/4 x to the raising that by 1, 3/2. And dividing by 3/2 is like multiplying by 2/3. And then we're going to evaluate from 0 to 4. So right now, outside we've got a constant of 8/27. I'm going to go ahead and just pull that out front. So we have 8/27. And then 4 into here would be 10 to the 3/2. And 0 into here would be 1 to the 3/2, or just 1. So this is irrational. We really can't do much to simplify this expression, so we'll just leave it like that. 8/27 times 10 to the 3/2 minus 1. If we wanted to get a sense of what that was, we could approximate that value with the calculator. But typically, I would prefer you leave all your answers as exact, since that is the exact answer. So here is our length. Now this one, the function was given as a function of x. We could also find lengths of functions as a function of y. Same formula, just the derivative of f of y. So you'd be differentiating with respect to y, and you'd be integrating with respect to y. So however that variable is given, that's how we're going to integrate.